Hey guys, these are your notes for section 10.3. We're going to take a look at geometric sequences and series. And a geometric sequence is when your terms are found by multiplying by a common ratio, and we're going to call that ratio R. And I forgot to give you an example. An example of a geometric sequence might look like this. Start somewhere, times by 3, times by 3, times by 3, and so on. R would be 3. We can define geometric sequences recursively or explicitly. Recursively means you have to always look back at the previous term. So to get a term, you take the previous term and you multiply it by your common ratio. The explicit form is you want a term, like maybe you want the 100th term. Take your first term times your common ratio to the power of 100 minus 1. Now, keep in mind, this exponent only rests on the ratio. It doesn't rest on the first term. This first term is like the coefficient of this power right here, okay? So this is attached to this, and then this is attached by multiplication. So in these, again, we're looking to see, are they geometric? And if so, what's R, the common ratio? You can see that you're multiplying by 8. Yes, it's geometric. R is 8. Times 2, times 3, times 4, times 5. No, it's not geometric. R isn't a constant throughout all the terms. You might say, oh yeah, I see, we're dividing by 4. Well, division by 4 does not determine geometric sequence. Multiplying by a fourth determines geometric sequence. In this one, we're given some information. Find the nth term. Again, that's telling you to write the equation or the formula. And after that, we're going to use a formula to jump to the 6th term. Not recursively, explicitly jump to the 6th term. So I wrote down that my first term is 3. I determined that R is negative 2. Kind of weird, but yeah, we're multiplying by a negative each time. Times negative 2, times negative 2, and so on and so on. So R is negative 2. Here's what my explicit formula looks like. A sub n equals A sub 1 R to the n minus 1. And then, so that's the answer to the first part. That's the find the nth term that they wanted. And then jump to the 6th term. Okay, so we got this, just sub in 6 for n. And this becomes negative 2 to the 5th power times 3, which is negative 96. There we go. Next one, find the equation. Again, write out the formula. Geometric sequence, here's some information. Here's what the formula is supposed to look like. We need A sub 1, we don't have it. We need R, we don't have it. Here's what we do have. I listed them out. Don't know, we do know. We do know. So keep in mind, to get to each term, you multiply by a constant. So do you agree that if you start at 12, and you go times R, times R, times R, times R, times R, you get 384. And that's the same as 12R to the 5th power. Divide both sides by 12. Just kidding. Divide both sides by 12. And some of you can do this on your own. Some of you are going to rely on your calculator. There is a way to do a 5th root on your calculator, on your scientific calculator. And if you don't know, just ask me. I'm happy to show you how to use your calculator. But think about it. You have to multiply by something 5 times to get 32. It's going to have to be a pretty small number and probably even. So I'm thinking 2. 2 times 2 is 4, 8, 16, 32. That's it. R is 2. So we know that R is 2. Back it up. Divide by 2, divide by 2. A sub 1 would be 3. So I've got A sub n equals 3, parentheses, R we found to be 2, to the n minus 1. All right, we're looking at nth partial sums of a geometric sequence. So just like we did with arithmetic, let's look at the sum of the first 8 or whatever. We're going to do that with geometric. Here's what it looks like. You've got a different formula. Now, on your formula sheet, you're going to have to know the difference between the sum formula for arithmetic versus the sum formula for geometric. Okay? This is the one for geometric, and it's got the power here, so that ought to be, and it's got R. There's your clue. The one with the R goes with geometric. That's your clue. So anyway, the sum of however many you want, we're going to do this math right here. So, using that formula, let's do this problem. Here's what this problem says. Hey, let's take your first 12 terms. Hang on a minute. I don't know what your notes say. We're going to start with 1. We're not going to make this difficult. That could have been difficult. We're not going to do that. Start with your first term, go to your 12th term. Easy. Okay? Let's do the sum of the first 12 terms. And this is how you get each term. Notice this looks just like the setup for the explicit formula. The setup for the explicit formula, you got your first term, you got R to this power. It's the exact same. So you all should look at this and be like, oh, first term is 15. R is negative 3. Like, you should be able to recognize that, what form it is, and then be able to pull numbers out of there. This is A sub 1, this is R. Because this looks just like the setup for the explicit formula. So here I go. This is the equation that we're going to use. I pulled it right up there, just color-coded some things. How many do we want? 12. What's our first term? 15. Oh, what if you didn't know that? What if you didn't recognize that? How do you get your first term? You do the math. You plug in 1. And you take 15 times negative 3 to the 0 power. So your first term is 15. We're following the formula. 1 minus R. Ooh, R is negative. Careful. Put R in parentheses. To the n power over 1 minus R. Be careful with your calculator. You have to know how to use it correctly. You have to know how to use parentheses. And you should get negative 1,992,990. Holy moly. But, I mean, if you really think about it, we're adding a list of 12 numbers. 15 was my first one, and I'm multiplying by negative 3 each time. All right. Here is the interesting stuff. Here is a couple days ago when I said, did you know that it's possible to add an infinite list of numbers together and get an actual answer? It just seems amazing. So it only works on some geometric sequences. Some, S-O-M-E. It only works on some geometric sequences. So, an infinite geometric sequence is convergent. This means we can add all the terms together. It's convergent if our R, the absolute value of it, so positive, negative doesn't matter, less than 1. We're looking for some type of proper fraction, some type of number between 0 and 1. Positive, negative doesn't matter because it says look at the absolute value of it. We can find the sum of the infinite number of terms if it's geometric and if R meets this requirement. And the series is called convergent series, meaning add them all together. If the absolute value of R is bigger than 1, so if R is like 2 or negative 3 or negative 1.1 or 1, the series is divergent and we can't add all the terms together. So whether you can or you can't, you're looking at R. R, the absolute value of it has to be less than 1. Now, in your notes, it gave you a summation notation here, which was kind of like wrong notation. I'm giving you a sum formula. This is going to get you the sum of your infinite number of terms in your geometric series. The sum of the infinite number of terms in your geometric sequence. I said that kind of redundantly. All right, let's see if these can happen or not. Are they convergent? Yes, I can find a sum. Or divergent? No, I can't find a sum. It all depends on what R is. So look at the way this is set up. This is set up for you in explicit geometric form. First term, which doesn't matter when we're trying to determine this. R, this is what matters. R is 2. The answer is nope. We cannot find the sum of all of them. This is divergent. Let's try this one. This one is set up a little differently for you. So just to kind of make you get it, I wrote what the terms are. First term is 3. Second term is negative 2. Third term is 4/3. Fourth term is negative 8/9. This is saying, can we add all these together? Can we add this with this, with this, with this, and so on and so on and so on? Let's find out. First term doesn't matter. It's all about R. So to get R, I can take this divided by this. So my first term was 3. R turns out to be negative 2/3. Does this meet this requirement? It does. This is doable. This is doable. So let me just to kind of familiarize you more with sequence notation, series notation, sorry. Here's what I did. I wrote this in normal explicit form. First term R to the, and said, hey, can we add all these together? Can we go from the first term all the way to infinity and add them all together? We can. We have this little formula up here that's going to help us do it. The formula says, if it's doable, you take a sub 1 divided by 1 minus R. 1 minus R. And you get 9/5. Isn't that kind of wild? This list of numbers goes on forever. And you can add them all together and get 1.4. 1.8. That's kind of cool. All right, keep those formulas handy. You don't need to memorize them. Just know which one to use for which type of problem. Keep them handy. They're going to be given to you on your test. Good luck.